Today, we're going to break down a fundamental task in natural language processing, named entity recognition, or just NER. This is one of those core skills a machine has to learn to really make sense of human language.
You know, when a computer looks at a block of text, it just sees a long string of characters. It doesn't inherently know that Apple is a company or that Tim Cook is a person. So the big question is, how do we teach it to find the important stuff, the actual names and concepts hidden in all that text?
And that's exactly our goal. By the end of this, you'll have a really clear picture of how machines turn that raw, messy text into structured, useful information.
Okay, let's build the intuition. The easiest way to think about NER is to imagine you have a set of smart highlighters. Each color is for a specific category, right? Maybe yellow is for people, blue is for organizations, green is for locations.
So let's take a real sentence from a news article. Right now, to a machine, this is just a sequence of words. Let's watch what an NER system does with its highlighters.
First, it spots Deepak Jasani. Now, how does it know? Well, based on patterns it's learned, things like capitalization and the common structure of names, it highlights this as a person. That's our very first piece of structured data.
And then it keeps going. It finds HDFC Securities. The word securities is a pretty big clue, so it gets tagged as an organization. See how it's already starting to tell the difference between different types of things?
And finally, it sees European Central Bank and marks that as an organization too. And just like that, what was once a flat sentence now has meaningful labels. We've pulled out specific, categorized information.
And that right there is the core of it. Formally, named entity recognition is just the process of identifying and classifying these predefined categories in text. It's a super important first step for extracting any real information.
Okay, so the highlighter analogy tells us what NER does. But how does a machine actually learn to apply those labels so well?
Well, historically, there were two paths. The old way was rule-based. You'd literally write rules, like any two capitalized words after Mr. is a person. And you can probably guess, that gets really brittle really fast. The modern approach is machine learning. Instead of us writing the rules, we just show the model thousands of labeled examples and let it figure out the patterns on its own. It's way more flexible.
The machine learning workflow is pretty standard. First, you need a bunch of text where humans have already highlighted the entities. Then you feed that labeled data to a model so it can learn. After that, you test it on data it's never seen before to see how well it does. And once it's accurate enough, you can use it to make predictions on new text.
Under the hood, a few key technologies make this possible. You have models like LSTMs, which are good at remembering context as they read through a sentence. We often pair that with something called a conditional random field, or CRF. Think of a CRF as a grammar checker for the labels. It helps make sure the sequence of tags makes sense. But the real step change came from transformer models like BERT, which can look at the entire sentence at once, understanding context from all angles.
So this isn't just an abstract computer science problem. Let's talk about where you actually see NER in the real world. You probably use it all the time and don't even realize it. For example, automated HR systems use NER to scan resumes and pull out skills, job titles, and companies. When you ask a chatbot to find pizza places near Central Park, NER is what identifies pizza places as a business type and Central Park as a location. News websites use it to automatically tag articles with the people and organizations mentioned. It even shows up in cybersecurity to find suspicious IP addresses or file names in giant log files.
All right, let's zoom out for a second. Why should you, as an engineer or data scientist, really care about this one concept?
It's because NER is that first critical step that turns unstructured language into structured information, the kind of information a computer can actually work with. So if there's one idea to remember, it's this. NER is the bridge from unstructured language to structured knowledge. It's how machines start to build a real understanding of our world.